I know Arrhenius Equation is a challenging topic for everyone that is studying kinetic at the moment, and they're going to have to apply it to paper 2 for AQA and EdXL and paper 1 for OCR students. Now, it's not too complicated as the equation. However, sometimes I think that there is a math, like we're lacking of the mathematical background to do some rearrangement and to do calculations with like natural logarithms. So that's what we're going to look at today. And I'm going to show you some exam questions that came up in the past that will show really the different variety of exercises and ways to apply this equation. Let's go. This is the latest worksheet that is on the A-level chemistry classroom. Now, the Arrhenius equation, I hope you have it clear in its standard form, where we have the rate constant, collision factor A, exponential factor minus EA over RT. Okay, the gas constant you're normally given it in the question or in your data booklet, and the temperature. So it's very, very important that you pay attention to the units. This is the first thing that I want to highlight because we have the gas content in joules, so will be the activation energy. So this is the first thing that I want to highlight. You're asked the activation energy often in kilojoules, and here is in joules. Then the temperature, of course, is in Kelvin. Notice the gas constant. So if you notice these units, you can't miss the conversion. Okay, so it's extremely important that you remember that. Okay, now this equation in the exponential form is not very useful and it can be a bit tricky to do calculations. And that's why, and I'm going to show you this, is that this equation is easier to use if you take the logarithm of each side of the equation, which results in the following equation, where we have the natural logarithm of k is equal to natural logarithm of a minus ea over rt. As you can see, it's kind of a linear equation now. The most important thing is that this equation takes the form y is equal to mx plus c, which means that we can put it in a graphical form, and we can do plenty of calculations with a linear graph, right? As you can see here, we have the intercept with the y-axis is going to be our collision factor, which we can calculate by reversing the natural logarithm, so doing its exponential. And then the gradient of the straight line will give us the activation energy. So the gradient is activation energy divided by gas constant. So of course you need to rearrange this to find the activation energy, always in joules, as I mentioned before. So as you can see, by taking the graphical form of this equation, we can do plenty of easy calculations. However, it gets a bit tricky when you're just asked, for example, to rearrange. And a question that I've seen coming up before is rearranging for the temperature. Okay, so again, it's not easy to work with logarithms or exponentials. Actually, logarithm is easier. Exponentials are more difficult. So what you can do is isolate the exponential term, because then you can treat this, you can do things with it to remove it. Yeah. In fact, if you take the natural logarithm of both sides of this equation, step 2, as you can see, we have ln k divided by a is equal to minus ea over rt. Now, we can rearrange for t. However, one important point that you must know is that the natural logarithm of two terms that are divided, it simplifies in minusing the natural logarithm of them. So if you're dividing two quantities, their natural logarithms will be minus, and that's why it's arranged in this way. I'm highlighting this specific arrangement because, guys, this came up in 2023. And I've seen that in previous questions, it was really not highlighted. Even in like other type of exam resources, it was not really clear, this arrangement. So here I gave you the solution, because also remember that the mark scheme, this is the mark scheme, it's really not clear and you can't get many information. So in this worksheet, you can really find the step-by-step solution. Just to show you a little bit the other exercises, then you would be able to download this worksheet. You will see that you have some graphical forms, or you have already simplified forms of the equation where you just need to calculate, okay? Or you need to actually do something graphically, either calculate the concentration, the activation energy, or you might have to even plot a graph like in this one. So as you can see, across the years, we've seen all of the different type of exercises. So like this, you can really, with this worksheet, you can really try it yourself. This worksheet is a small piece of study material that you can get from my A-level and AS chemistry crash courses. You can join the full membership with private lessons weekly and group lessons towards the exams and the key dates during the year to get the most complete possible exam preparation and to tackle the hardest exam questions and get an A star.